Hello, algebra students. Today we're going to be looking at patterns and some different ways that we can um, explain what we're seeing in patterns. So to start with, I want to look at a list that is starting with these numbers, 1 and then 5 over 2, which is really 2.5. I know that we haven't talked a great deal about exponential functions, but exponential functions just mean that I am multiplying by something every time instead of linear, which is what we're going to do second, where we're adding the same amount every time. So in here, to go from 1 to 5 over 2, well, clearly if I started with 1 and I multiplied by something, it's got to be that 5 over 2. What I want here is the next three numbers in the list. So if it starts with 1, then I've got 5 over 2. And then if I'd multiply by 5 over 2 again, I would have 25 over 4. Multiply by 5 over 2 again, and I would have 125 over 8. And let's do that one more time. 125 times 5 is 625. And I'll be at 16 for my denominator. So that's how it's multiplying. And you could certainly change those into mixed numbers or decimals if you'd like to. When I look at this linearly, so it means that I'm adding the same thing every time. Remember, again, this 5 over 2 is really 2.5, if that helps. So I'm adding really 1.5. Or actually, I think even an easier way of seeing this is, instead of seeing this as 1 and then 5 over 2, what if this was really just a 2 over 2? And then I went to 5 over 2, right? 2 over 2 would be equal to 1. 5 over 2 would be the next number. So I'm adding 3 over 2, which is another way of saying 1.5. So if I had 1 as my first number, and then 5 over 2, the next number after I add another 3 over 2, so I'm keeping that same denominator, that would get me to 8 over 2. I don't really like that number. I would much rather see it as just a 4, but if we're just keeping this pattern, it might be easier to see it this way. Then I would add another 3 over 2, so I would have 11 over 2, really 5.5 right there. And then I would add another 3 over 2, which would get me to 14 over 2, which would be 7. Right, so if I'm adding 1.5 each time, adding 3 would jump over that middle step and then add 3 again, so that jumps to this step. So that's different ways that we can look at this. Just having the first two numbers in a list, if that's the only information that we're given, we don't actually know what pattern it should be. So we have to look at different options that we might have. Here I've got a pattern. It says that it's a pattern of sticks, which is fine to call it that. I usually see this as like toothpicks. I've seen these kind of patterns all set out with little bitty toothpicks just so you can kind of have some manipulatives that you can move around. So the pattern is definitely changing. We've got these really equilateral triangles and we're adding on every single time. So you can either be looking at this as I had my original triangle right here, and then I added on 2 more segments, or you could say, oh, now I've got 2 triangles. And then I had step 1, which was right here, this parallelogram right here, and then I added on 2 more segments, or I added on 1 more triangle. So there's different ways that we can look at this. And to show our prediction for the next 2 steps, I could have for step 3 then, I would have my original triangle. You know what? I'm just going to add on to this one, I think. I'll just switch colors. So for step 3, I would add on another segment going this way and this way. So that would be step 3. And then for step 4, I would add on another one going this way and this way. So this is really step 3 and this is really step 4. Just saving some time instead of me drawing all that out. Now, when I'm looking at these tables of how we can be considering the the number of segments or sticks or the number of triangles. I'm sorry about that. If I look at just the number of sticks, which is what I've got in this first table, so this is the number of sticks. I had in step 0, 3 sticks. In step 1, I have 1, 2, 3, 4, 5 sticks. Right up there. In step 2, I added 2 more, so that's how I get 7. In step 3, that's where I added the purple lines on right there. It's increasing by 2 every time, so this one would have been at 9. It doesn't ask for step 4 or step 5. So we could certainly find those in between steps, or we could be looking at what the pattern is doing here, so I don't have to keep finding all of the in-betweens, like to go from 6 till 11, for instance. So what I'm seeing here is that my beginning amount, thinking about maybe slope-intercept form, for instance, my initial amount is 3, but it's increasing by 2 in every step. So here in step 1, it did increase by 2, and in step 2, considering going all the way back to here, it's now increased by 4. And then going all the way back to here, it's now increased by 5. So it's really 2 times the number of the step that we're adding in. I think I said 5 here, and I didn't really mean that. So what's happening here for my step is I started with 3, but I'm adding 2 for every single step. So again, instead of finding all these in-between steps, let's just make sure that that works. So when I put in my 2, 2 times 2 is 4 plus 3. Yep, that was my 7. If I put in the 3, 2 times 3, that's the 6 that I was saying that I was blanking out on, and I add the initial 3, that does give me 9. So when I put in 6, instead of completing the pattern and drawing more out, 6 times 2 would be 12, plus 3 would be up to 15 at that point. For 11, I would have 2 times 11, which would be 22, plus 3 would be 25. So you can find a pattern there if we're looking at the number of sticks. If instead we look at, let's see here, I want to erase at least this part right there. Actually, I'm going to erase all of this, I think. If I look at another way of looking at this pattern, at step 0, I still have 3. That makes sense. But now when I say at step 1, I've got 4, well, clearly it's not the number of segments that I have. But if I look at the perimeter, I have 1, 2, 3, 4 for the perimeter. When I look at step 2, I have 1, 2, 3, 4, 5 for the perimeter. So if I would continue that pattern, now it's only increasing by 1 in the perimeter each time. So that means that for step 3 then, I would just add 1 on and I would have 6. I have this one filled in. So if you wanted to, again, you could certainly say, well, that means at step 4 I'd have 5, and at step 5 I'd have 6. Nope, I messed up there. This would be 7. This would be 8. I'm so sorry. And then 9. So it's increasing by 1 every single time. So that's just saying that I'm going to have whatever step number I'm on. I want you to notice that this is just increasing by 3 every time from the step number. So it'd be the step number plus 3, which is going to give me at 11, that would be 14 for the perimeter. So this was the perimeter. So I've already kind of talked about this, what's being represented in each row. In the first one, we're talking about the number of sticks that we're using to make the entire shape. And in the second one, we're looking at just the perimeter. And I want to know if these patterns are linear or exponential or neither. So because each of these looks like slope-intercept form and it's just adding every single time, that's just going to be linear for both of them. Here's another pattern. More sticks. And I've got two different people that are looking at this pattern and seeing it different ways. So Lynn looks at this and says, okay, so there's zero here. Step 0 has 1 stick. Step 1 has 2 sticks. Step 2 has 4 sticks. It looks to Lynn like it's doubling every time. So Lynn says the next one's going to be 8 sticks. Andres, another student, looks at this and says, no, I think it's going to be 7 because we're going to add 1 stick to get to here. And then we're going to add 2 sticks to get to here. And then the next step, we would add 3 sticks, which would be 7. So it's looking at the pattern. And again, there's not enough information at this point to know for sure which way it goes. So, when we're asking how each student is seeing the pattern growing, again, Lynn is saying that it's doubling, and Andre is saying that we're adding. So when we're doubling, when we're multiplying, that's an exponential kind of a growth, and Andre is adding, which is a linear kind of a growth. So let's figure out how many sticks they would have in each of their predictions. So if Lynn is correct and we're doubling every single time, then that means that the next one here, the third step, would be at 8. And then again, we've got some missing steps. We've got 4 and 5 that are missing. We could figure out step 4 would give me 16, and step 5 would be 32, and step 6 would be 64. But again, I think that we can find a good way to write out this pattern so we don't have to do like 8 or 7 and 8 to get up to the 9, for instance. What I notice here is because everything is being doubled, that means that we're multiplying by 2 every time. I just want to figure out how many 2's I've got each time. Well, if I had 2 to the first power, I would have 2. 2 to the second power, which is my step number right there, I'd get 4. 2 to the third power gives me 8. 2 to the sixth power is actually 64. 2 to the ninth power, which is a really big number, that's going to be 512. And that means that for my pattern, I would say whatever step I'm on is the exponent that I'm using. So this is going to be 2 to the nth power. Andre, because we're looking at this linearly and Andre is just adding sticks every time. So had 1 stick, added 1, and then added 2, and then if we would add 3, that would get us up to 7. And then again, I know that 4 and 5 are missing. So for step 4, if we would add 4 to this, we would be at 11. And at step 5, if I would add 5 to that, I would be up to 16. And then here I'm going to be adding 6, so that'll get me up to 22. And then to keep on going with this pattern, it's difficult because there's not a nice, easy way to just write this out. I really can only think that I'm going to have to actually figure out these in between steps now. So I know what step 6 is. Step 7, so we added 6 to get to here, so I would add 7, that would get me up to 29. And then step 8, I would add 8, which would get me up to 37, and then I would add 9 finally here, and that's going to get me to 46. So we can find that pattern, but it's certainly not as easy to do as if we can just get an actual formula that we'd be using. So then my last question is, I want to know what kind of pattern these are. So Lynn's pattern was called exponential because we're multiplying by something every single time. we're multiplying by a constant factor every time. And Andre's, yeah, there's a pattern. It's not linear because we're not having a constant rate of change. It's not increasing by the same amount every single time. So it's not linear. It's not exponential. We're not multiplying. That means that this one is neither. Still a pattern, just not one of our patterns that we're used to yet. And for this one, now we've got some dots that we're looking at. And it asks us to find how the pattern is growing. So clearly we're getting more every time. Each of these has 3 dots in each, I guess, column or row. It's not really columns because they're kind of diagonal. So in each of these, I'm going to call them rows, there's 3 dots. So here I've got 1 row of them. Here I've got 2 rows. Here I've got 4 rows. Here I've got 8 rows. So it's clearly doubling each time. So I had 3 in this one, and then I have 6, and then I have 12. The next one would be 24. To save time, I'm not going to actually draw out the next one, but it would have 48 dots. It would have those rows of 3, and there'd be 16 rows of them. So we have step 2 is 12. We have that step 3 is 24. And step 4 we figured out would be 48. So we could just find the in-between. We could find step 5 if we wanted to, which would be, step 5 would be actually 96. And then we would double that one again and we would get 192. To be able to find for any number of steps for the n here, what I want to remember is, yes, it's doubling every time, but I didn't just start with 1 this time. I started with 3 dots. So that group of 3 is getting doubled that many times. Okay, so that's how we would write that. And this one is exponential. I know, again, it didn't just start with 1, but it's exponential because I'm multiplying by 2 every single time. For this last example, we've got another pattern of dots, and let's take a look at what's happening here. In step 0, I hope that you see that this is like a pentagon, right? It's a 5-sided shape. And then in step 1, it's almost like the pentagon is kind of growing arms. So we added an arm on each side, or 1 dot on each side. So 1 dot, but 2 sides. We added 2 dots. Here we added another one on each side. So 2 dots here and 2 dots here. So it increased by 4 from the original one. So each time it's just adding 2 more to the step before it. So if I would try to draw this, I guess I would have my pentagon, and step 1 had 1 extra dot on each side. Step 2 had 2 extra dots on each side. Step 3 would have 3 extra dots on each side, right? And remember, those are the extra dots because the original pentagon had those 5 dots to start with. So step 2 on this had, well, let me back up a step. Step 0 had 5 dots. Step 1 had 7 dots. Step 2, when I added 1 more dot on each side, so 2 more dots, that's 11. I'm sorry, that's 9. Then the next one, the one that I drew right here, I had 3 here and 3 here, plus the original 5. That's going to be 11. So it's really just increasing by 2 each time. So that's going to be 13. 5 isn't on here, but that would give me 15. And then 6 would be 17. And to write that out, again, we're adding 2 dots on each step, but I started with 5 dots. So I started with 5 dots, and I'm adding 2 dots for every single step. And this one, because it is adding the same amount each time, that's going to be linear. Okay, so I hope that looking at these patterns is kind of getting your brain warmed up and thinking about different ways that we can look at patterns and be able to write them out. So would you please make sure that you go ahead and check Schoology, see what your assignment is today, see if we've got a formative for you to do, and let your teacher know if you need any help.